Hi, this is practical exercise 2. Today we will design a half subtractor using VHDL and review our designs. So these are the topics we would be covering today. We are covering from the basics. So if you are familiar with some topics, you can jump to next part of this video. First, we will quickly understand the half subtractor and its requirement. Then we will create a truth table, and then based on that we will define the expression for half subtractor. Then we will code our VHDL design using expression which we created. Then we will quickly simulate and synthesize our design. Next we will define our behavior of our half subtractor in VHDL. Then we will simulate half subtractor behavior. Next we will review synthesized result and we will see tool generated schematic for half subtractor. Next we will review synthesized design and we will see tool generated schematic for half subtractor. Next we will quick compare both the simulation results and synthesized results. So let's start. So this is our half subtractor module. So we will have two binary inputs, input A and input B, and at the output we should get difference of both the inputs and borrow as second output. First step is to create the relation between output and input for all the possible values of input A and input B. So there are two binary inputs, means 4 possible combinations. So when both the inputs have same value, then difference will be 0 and borrow will 0 too, right? Means first and fourth set of input. Now second set, when A is 0 and B is 1, difference is very clear, that is 1, but A is lower value. So to subtract here, we need to borrow 1. So the borrow output is 1. Next, check third set where A is 1 and B is 0. Again difference is 1 here, but now A is higher value. So no borrow, means borrow output will be 0. So this is our truth table for half subtractor. Now write the expression for this design. So first is difference and the output is 0, 1, 1, 0 for the respective inputs, and we know this is simple XOR gate. So difference is A XOR B. Now borrow. So this output do not fit straight with any basic digital gates. So this means you actually need to create expression for this. Try this. What if you invert the value of input A using a NOT gate and then use a AND gate with this inverted signal and input B. So invert input A. So signal S is 1, 1, 0, 0. Now use AND gate between this and B input. So 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. 1 and 0 is 0. So this matches our requirement. So we can use this expression. Looks tricky, right? This was the way what designers used to do in early times of chip designing. Think about the complexities. However, there are a couple of ways to get those expressions from such truth table, but still that was painful and time taking, and chances of errors are also high, and you can assume if someone asks for little change in your design. Anyway, we do not use this approach of designing now. Luckily, we have hardware description language, so we only tells that we want this output from these inputs, and the tool will do all the job and design those structures and expressions for us. How easy and convenient, right? So in this video, first we will write our VHDL design using the expression which we designed by our own, and next we will make same design by defining the behavior of our half subtractor, and then let's tool figure out that what expression and structure it is designing for us. Then we will simulate both the design and compare if we see any difference or not, and finally we will synthesize both the designs and we will see that what structure those tools design for half subtractor and if it is different from our expression or not. So let's start the practical exercise. We will use Xilinx ISE for today's project. So first we will open the Xilinx ISE project navigator. It is opening now inside VirtualBox. We will double click on this project navigator and we will open this. It is opening. First, we will create a new project. So go to Files tab. Now click on New Project. Give the project name. Suppose we give half subtractor 01. Click on Next. We are not working on FPGA, so you can select any device from here. But make sure you select VHDL as your preferred language because we are writing code in VHDL. Click on Next. So this is summary of our project. Review the information and click on Finish. Now it is creating project for us. Next, we will create a new module. So navigate to this button and click on New Source. Now select VHDL module and give the file name. Suppose we give half sub01. Click on next. This is our entity name. This is our architecture name. Now give the port list. So A, select direction in for input type signal. B, direction in. Div, direction out. Select direction out for output type signal. Borrow, direction out. After entering all the ports, click on next. This is the summary of our VHDL module. Quickly review the information and click on finish. So this created the VHDL structure for us. Entity is already there and VHDL architecture body is also generated. We just need to describe our design. I have already written the expression for half subtractor, so we will copy paste to save time. These are the same expression which we designed in the slides for half subtractor. So open this file, copy the expression and move back to project navigator. So this is our architecture body. Now paste them inside the architecture. Perfect. Now save our VHDL code. This is our VHDL module named as half sub01. Select this. Adjust all the windows little. Next we will check syntax. So expand the synthesize tab and click on check syntax. So syntax is okay. Next we will do simulation. So select the simulation tab from the top. This is our half sub01 module. Now expand design utilities and double click on simulate behavior model. This is simulation window. You can see waveforms here. First give a restart. So click on this restart button. Now give inputs. You can force constant here, but I will prefer to give a clock. Both are okay. So select A, right click, select force clock, fill the data, click apply and click OK. Next select B, same, right click, force clock, fill the details, click apply and click OK. Now run the simulation. We will run for 1 microsecond. So click on this button. It will run the simulation for the time period which you specify. Means you can change the simulation time easily if needed. Now adjust the zoom level little. Perfect. So we can see all the values in one screen. Let's review our output. First move this yellow marker to our first instance. So here our inputs are 0 and 0. So difference is 0 and borrow is also 0. Next move marker to second instance. Now inputs are 0 and 1. So difference is 1 and borrow is 1. Next move marker to third instance. Here inputs are 1 and 0. So difference is 1 and borrow is 0. Next move marker to fourth instance. Here inputs are 1 and 1. So difference is 0 and borrow is also 0. This means our half subtractor design is good. Now we will go back to project navigator window again. Okay, select the implementation tab again from the top. Now we wanted to see the RTL schematic of our design. So expand synthesize tab and double click on view RTL schematic. It is loading. Now select the second option and click on OK. So this is our half sub01 module. A and B are our two inputs. Difference and borrow are our two outputs. Double click on this module and it displays the gate level structure. Zoom out little. These are our inputs A and B. This is AND gate where A input is inverted before doing AND. And we are getting the borrow output from this AND gate. Next, this box is actually XOR gate. So inputs are A and B and output is connected to difference. Let's double click on this and expand this structure. So if you have ever seen XOR gate structure, then you can relate this architecture. Let's create another module for half subtractor. But now we will not tell the gate structure, but we will give the inputs and output relation, and tool will create the gate level structure for that requirement. So again, navigate to new source, click on this button, select VHDL module, give some file name, suppose half sub02 this time, click on next. This is our entity name, half sub02. This is our architecture name. Now give the port list. This time I am giving the vector type signal for both input and output for ease. So type D in, direction is in. Now tick this box. This is indicating the vector type signal. And next give the MSB and LSB. So D in is our input, which will have two signals inside. So it will be 1 down to 0. So type 1 in MSB and type 0 in LSB. Same the out, tick this box and set MSB 1 and LSB 0. So one output will be our difference and another will be our borrow. Now click on next. This is summary. You can review the information here and then click on finish. Now the VHDL structure is already written. Entity is already there, and for the architecture description we have the save file, so we will open that and copy paste our code. So open the saved file. This is our code. Copy this. Now go back to the project navigator, paste the code inside the architecture. Simple. So it is done now and our code is ready. Next we will save this. Now this is important step because we have two modules now inside the same project. One is half sub01 and second is half sub02. And because we are working on half sub02 now, so we need to select it as a top module. So for that, right click on this module and choose set as top module. Click on yes. Now this module is our active module, and now you can see the more options below. Now the steps are same. First we will check the syntax. So navigate to the synthesize and double click on check syntax. This is OK. Now select the simulation tab from the top. This is our half sub02. Now go to simulate behavior model and double click here to open it. So this is our waveform window. These are inputs and outputs. First restart the simulation. So click on this restart button. This time we will force values instead giving clock. So right click on input D in. Now select force constant. Note that I have selected this vector input. So we will give 2-bit data for both inputs. So give value 0 0, then apply and OK. Now we will run this for 1 microsecond. So click on this button. Now change the values. So select D in, right click, force constant, give 0 1, apply, OK. Now run again for 1 microsecond. Change the values again. So select D in, right click, force constant, give 1 0, apply, OK. Now run again for 1 microsecond. Change the values final time. So select D in, right click, force constant, give 1 1, apply, OK. Now run again for 1 microsecond. Let's adjust the zoom level little. This is good. We can see all the instances in one screen. Now move the yellow slider for first instance. Okay, so D in is 0 0, then D out is 0 0, means difference is 0 and borrow is 0. Next, move slider to second instance. Now D in is 0 and 1. So difference is 1 and borrow is 1. Next, move slider to third instance. Now Tin is 1 and 0. So difference is again 1, but borrow is 0. Next, move slider to 4th instance. Now Tin is 1 and 1. So difference is 0 and borrow is also 0. So this half subtractor is also works fine, right? Now let's see the gate level structure for this. So we will go to project navigator again. Select the implementation tab from the top. Now go to the synthesize tab and double click on view RTL schematic. Select this second option here and click on OK. This is our half sub 02 module. D in is our input. D out is our output. Double click on this and expand, and that will return a fixed room type structure. Let's open the technology schematic now. So double click on view technology schematic. Select this second option and click on OK. So this is our module. D in is input, which is vector for 2 binary inputs. D out is output, again vector type for difference and borrow. Double click on this, zoom out little. So there are 2 boxes, one is for difference and another is for borrow. First open the top one, so double click. This is AND gate where input A is inverted with NOT gate, and this is our borrow output, remember. Let's open the bottom one. This is our XOR gate and the output is difference. This is the same structure which we have created for our half subtractor. You can also see the truth table for this structure as well. So click on truth table, and this is the relation between inputs and outputs, and this is a XOR gate. You can also view the expression for this. So click on equation tab and it will display the expression for the design. Also you can see the K-maps for this. This was one of the simplest design you can try to start practice. This is equally important so that you can familiar with the tools and its features. This is just a start. Together we will design many different type of systems and we will do the projects too. So stay tuned for the updates. Like this video, comment on video and share this video. And don't forget to subscribe to learn and grow community. Thank you for watching.